is January 23rd, 2012, and this is AP Statistics at Berkeley High School, and we're ready to start Chapter 9. Chapter 9, we're going to start our introduction of significance tests. Now, Chapter 9 is broken into 3 sections. Like the previous chapter, when we introduced the idea of confidence intervals, we introduced the general idea first, and then we went specifically to plans of attack for the distribution of sample proportion and then the distribution of sample mean. We're going to do the same thing here. I'm going to introduce this really big idea first, the idea of significance tests, the basics. Then we're going to say, how do we apply it in particular to problems of sample proportion and population proportion? And then in the last section, how do we apply the things that we're going to pick up in this section to the idea of the distribution of sample mean and the idea of population mean? So, by the end of this section, we should be able to do these things. We should be able to correctly state a correct hypothesis for a significance test. We're going to be able to talk about what do we mean by a p-value, and what does it mean in the context of the problems that we're trying to solve. We're going to have the definition for type 1 and type 2 error when it comes to play having to do with significance tests, and we're going to have to talk about what are the consequences of these errors. And then lastly, we're going to be looking at how to calculate the probability of the type 1 error and the relationship of the probability of the type 2 error to something called power. We'll probably get through the first 2 bullet points and a little bit into the third, and that last bullet point we'll probably have to wait till tomorrow. All right? So let's get started. In the previous chapter, we talked about confidence intervals. And I just want to go back to this really, really big idea. We wanted to make a statement in the form of a confidence interval that said, even though we can't interview everything in a population, we can still try to make statements about what's going on at the population level. Even though I've only interviewed 1,000 people, I know with a certain amount of confidence that the true proportion of people who support Mitt Romney is between this number and that number. It's looking at a sample to try to make a statement about what's going on at the population level. That's one kind of statistical inference. Remember, the word inference means to take some information and infer, based on that information, onto some bigger idea. I look outside, and I look at the rain, and I infer that if I step out in the rain, I'm going to get wet. I'm looking at some information to then make a statement, a broader statement. I infer from the fact that I interviewed 1,000 people, and 35% of them said they support Mitt Romney. I can infer that the true proportion of people who support Mitt Romney is somewhere between, let's say, 32% and 38%. Taking a small bit of information and widening out its scope to infer. Well, the second kind of inference that we do in this class is called a test of significance, or significant tests. And it has a different goal. Its goal is to look at the evidence provided and then make a statement about whether a claim is true or not. Provide some evidence and then see whether that evidence supports some claim. Now, typically I start this idea out with a demonstration. You know what? I do not have a quarter on me. Can anyone lend me a quarter for a demonstration? Paul, you can come to my rescue?
No, I don't have a quarter. I have $5.
Does anyone have a quarter? I need a disc that's silver. Okay, great. So we're going to start with this as a demonstration. Get out your notes because you're going to want to keep some data for me. All right? Okay, so even though I said get out some notes, Nate Davis is like, you can't? Your arms are broken. Really? This is how we're going to start the second semester. Okay. All right, I'm going to flip this coin, and I want you to keep track of how many heads I get. All right? Everyone ready? Except for me? You lent me a quarter. I'm going to give this back to you when I'm done. Okay, here we go. Heads. There's one. Heads. We're due for a tail. You learned nothing from the previous semester. We're due for tails. Why am I not due for a tail?
You got two heads, why can't I get a tail?
So the coin has memory. Or what is the important concept that they're totally disregarding? That each flip is independent. Independent. It doesn't remember. It's not influenced by previous events. So, head. Head. I smile all the time, Abby. Head. Point is horrible?
False coin is magic.
Head. That's 7?
That's 6.
That's 6?
That's so. That's exactly.
That is definitely 6.
That's 7.
That's 6. That's 5 and 1.
6.
It's 6.
Yes, but you thought I was due for a tail as well, so I... Alright, so I'm going to stop there.
He just doesn't want to get a tail. Let's do one more.
No, because Abby, you were correct. I was lying.
Yeah, you were lying.
But let's say I didn't admit to it. Do you have proof? Now, let's get rid of the word proof. Do you have evidence to suggest that I was lying? No, you gotta pretend I wasn't smiling. Dad, I look guilty. No, I mean, you look guilty doesn't apply in the court of law. It doesn't apply in this class either. Yes, me telling you you're lying is definitely evidence that okay, no. I'm trying to get to a really, really big point here. You want to say that I'm lying. Is there any evidence to that claim?
No, it's really, really unlikely to get 6 in a row.
Say that one more time, Cody.
It's really, really unlikely to get 6 in a row.
It's really, really unlikely to get 6 in a row. Heads. How unlikely is it? How unlikely is it that I would get 6 in a row heads? 0.5 to the 6th. 0.5 to the 6th power. And I don't have my calculator, but a lot of people, you guys have your calculators. Can you do that calculation for me, please? 0.5 to the 6th is a 0.0196. 56? 0156? Okay. It's really improbable that I would get 6 heads in a row. That's evidence. A lack of probability, a small probability, is evidence that something is screwy here. It's unlikely that I would get that many heads. I want you to think about that claim for just a second. You are going to suggest that I'm lying, which is something that you rarely do to teachers, I think. And I do believe it's the first time in this class that anyone said that I was lying. Is that right? Can anyone think of an earlier time this semester or the previous semester that you said, "Oh, Mr. Fair, I'm so crap"? No? All right. So against the situation calculation against the evidence of 20 weeks of classes in which I have been hopefully fair and honest, Abby wants to make the claim that I'm lying. All right? She uses this idea that it's very improbable that I get that many heads in a row. And she calculates the probability. But there's a strange contradiction built into this system. How did we calculate the probability of me getting 6 heads in a row? You had to make an assumption. You had to say, I believe the probability of getting a head is 0.5. In order to prove that I'm lying, you had to first assume, for the purpose of doing this calculation, that I was telling the truth. You had to assume the exact opposite of what you wanted to prove. Let me say that one more time. In order to do this calculation of probability, which is evidence that I am lying, you had to assume first that I was telling the truth, which is the opposite of what you wanted to prove. Let me try this one more time with a different analogy. Okay? I make the claim that I am an NBA All-Star. And I drive a 2001 Saturn L. Saturn L was the base model Saturn for that year. The car that I drive every day does not have power windows, does not have power locks, does not have cruise control, does not have a CD player. What's that? And I'm an NBA All-Star. Jason. Jason, you are claiming that I'm a liar. What is your evidence?
At least a CD.
At least a CD player. Okay, so let's dissect his argument, which is a perfectly valid argument. Ready? If I was an NBA All-Star, I would have a car with power windows and a CD player. Oh, please.
You better play. NBA All-Star doesn't have. I don't know.
You probably don't drive.
They're all in cribs, man. What if it's not important to them? They don't care about it.
Okay, how about this?
What about
I am an NBA All-Star,
No, you're not.
and I live in the city of Detroit in a house that's worth $80,000.
What if you're an Amish? You're an Amish.
I'm an Amish NBA All-Star. That's right, because I'm driving a cart.
You're driving an
It could be
Amish car.
true. What's that?
You're driving an Amish car.
Well, he said I'm Amish, so I'm driving a horse and buggy. Okay, but no, I'd rather go back. Let's combine Jason and Bradley's argument. Jason's argument that I'm not an NBA All-Star starts with this statement. If you were an NBA All-Star, you would have a car with power windows. Or at least a CD player. Now, let's combine it with Bradley's argument. We don't know that all NBA All-Stars have power windows on their cars. Although
I'm 100% confident.
I mean, there's a possibility that they drive something vintage. You know, they drive a 64 and a half Ford Mustang.
It's custom and it's gonna have a CD player.
Okay.
Why would you do that? That would ruin it.
Because it's a really cool car.
Yeah, but why would you put a CD player in it? Or power windows?
No, I don't know.
That would ruin it. Get a different car and put
A
a
friend,
CD player in it.
a friend of mine restored
If you have the money.
a friend of mine restored a 65 Ford T-Bird. Beautiful
CD
car.
player.
No, he thought there are manufacturers that will create a radio that looks exactly like the original Thunderbird radio, but have a CD player. Okay, so anyway, so let's go with, let's combine Jason and Bradley's argument. Let's combine Jason and Bradley's argument, which is, if I was an NBA All-Star, Jason says it is, hi, hello, hi Sophia, hi Mr. Fader. Nice for you to join us. Why don't you have a seat here? We're in the middle of a lecture, and then I'm going to get you caught up with some of this. All right. So, Bradley's argument, would you say that it is improbable that an NBA All-Star has manual windows? Would you say it's improbable? I think most people at least agree that it's very improbable.
Well, there's only like 24. I think Kevin Love has
All right.
I know Bron's probably a Lamborghini.
Okay. So to finish off Jason's argument, it goes something like this. If Fedor was an NBA All-Star, then he would have a car with power lock or power windows. And because he doesn't have a car with power windows, he can't be an NBA All-Star. He uses the statement if. Assuming I was, you would expect these sort of consequences. A better car. A house that's worth more. Taller.
I mean, Spud Webb was I don't think he's making a statement about their car.
Spud Webb still was an odd, improbable thing.
I mean, yeah, you can. You just gotta have.
We don't know. Cameron. Yes, you can be short and white.
I'm not Cameron.
Sorry.
I've been here for like 4 or 5 months. Cameron.
Okay, what would you like to call me? Conrad.
Call him Baldy.
What? Rod. My cousin would have a problem with that. Yeah. Rod. Okay.
So do you guys work together?
Rod and Todd, yeah. Okay. So Conrad, I am evidence that you can be both short and white at the same time. And I believe, and an NBA All-Star, we have no evidence that has ever happened. All right.
Steve Nash, yeah, Steve Nash is like 6, kind of tall. His hair makes him taller than what he is.
And I don't have that advantage, do I? No. All right. So, in order to tear apart my claim that I was either telling you the truth when I was flipping the coin, or that I'm an NBA All-Star, you can make the assumption of truth. You can make the assumption of NBA All-Star-ness, and then see if it ever leads to something that's totally improbable. That is the essence of what we're doing in this class right now. We are going to make a claim which is totally not backed up by facts. Fedor's telling the truth. Fedor's an NBA All-Star. And then we're going to go through the process of saying why that claim is probably false. All right? Probably false. Could it be, in fact, that I could flip a coin 6 times and get all heads? Sure, it could happen, but it's very improbable. And again, we say the improbability of it is evidence against that initial assumption that we just made. The improbability that I drive a Saturn L, given that I'm an NBA All-Star, is so small that it's evidence against the claim about being an NBA All-Star. Bradley, you have a look of disbelief on your face again. Please, go ahead.
Why don't we call one? We should call one. We're not speaker.
Yeah. I'm sure they're taking calls at this hour of the day.
Can't look it up online. You probably
Okay.
Google
We
it.
could, okay. We can, okay. What we can do, we say, okay, the car is not one thing, is one thing. The height thing is another. Okay. Would you call that a stronger argument?
Yeah.
That there's only been one 5'7" NBA All-Star ever, and so it's very improbable. Okay, and then also that I'm 47 years old, and 5'7", and an NBA All-Star. There's never been someone who's been that old, that short, and an NBA All-Star.
And that's skin color.
And that's skinny.
Skin color.
And a
That's,
teacher.
what's that?
And a teacher.
And a teacher. All right. So I think we've got as much out of this idea as we can. Let's continue on. All right. So
Response to the AP exam, we all start writing about like Mr. Fedor being short and why he's
here's the idea that in book fashion of what I was trying to get at. A significance test is a formal procedure for comparing observed data to a claim. We'll call that claim a hypothesis, whose truth we want to assess. The claim in the first demonstration, Fedor's telling the truth. We want to assess that statement. The claim is a statement about a parameter. This is where the NBA and the height thing would probably work out well together. Like the population proportion or the population mean. We express the results of the significance test in terms of a probability that measures how well the data and the claim agree. I want to, again, hone in on this fact that this hypothesis, the claim, is actually, in most procedures, we want to prove it false. But the claim itself then has to be the opposite of what we want to prove. You want to prove that Fedor's lying? Start with the assumption that he's telling the truth. You want to prove that Fedor's not an NBA All-Star? Start with the claim that he is an NBA All-Star. And then collect evidence against that claim. I am going to refer back to the coin flipping example many times during the next 4 chapters. Always with the idea that our null hypothesis, the thing that we're trying to assess the validity, is something that we think is false. All right. So here we go. This chapter is all. This particular section is all talking about the underlying logic of this kind of test. How can we perform tests having to do with population proportions or population means to try to assess their validity, to find out whether they are true or false? Tell me when you're ready to go on to the next slide. I should say it the other way. Is there anyone who needs more time on this slide? Nope? All right. So, statistical tests are claims about a population. Hi, Danny. So statistical tests are claims about a population. In the first example that I did, the population is all the possible coin flips that I may make with that quarter. Can I give you a quarter back? Okay, good. The test might say something like this. If we took many random samples, and the claim were true, we would rarely get a result like this. If I took many coin or samples of 6 coin flips, and the claim that I was telling the truth was true, rarely would I get 6 heads. we can measure the strength of the claim, or strength of the evidence against the claim, by looking at it the proper probability. So here's a claim and response. Let's say someone claims that they're an 80% free throw shooter.
8%?
80%.
Oh, 80. I'm 8%.
Someone says, I'm an 80% free throw shooter, and what do you say? I don't believe you.
It depends on who it is.
What if it was me?
I don't know.
Make it easy on you. So you say, Jason, let's have a test.
Although I've never seen you shoot basketball.
You're not missing a thing.
The guy
If you're looking for hilarity. All right. So let's say Jason says, here, I'm going to have you do 50 free throws. And then the question is, from those 50 free throws, I make 32 out of 50 of them. That's at 80%. But, Jason, would you accept only 80% or above as being evidence to the claim I'm an 80% shooter? Or could I be like one short of 80%, and that would be nice? That's really close. That could just be chance variation happening. So I could miss one. I could be one below 80%, which would be what? 39.
Right.
And you'd be okay with that. Do you understand what we're talking about, Jacob?
What?
Okay, he says I'm going to shoot 50 shots. Okay, exactly 80% is making exactly 40 out of those 50, is it not?
Yeah.
Yeah. What if I made 39? It's not 80, but is it so close to 80 that we think that that could just be random chance?
Chance variation.
Just chance variation. What if I only made 38?
Yeah.
37?
I don't know about
36?
No.
At what point does the number of free throws that I make get so far away from the expected 40 that you say, no, you're not a 80% shooter? Well, let's talk about how we can break this problem down into a procedure in which at the end of it we have an expression of whether we believe or not believe this claim. First of all, we could do something like, I've got computer software and I can simulate 400 sets of 50.
How do you simulate something shot though?
How do I simulate something shot?
Yeah. I mean, like, your skill might not match the computer skill.
No, it's not about matching the computer skill. It's saying we have the ability to generate random numbers, do we not? The answer to that question is yes, Paul. We do have the ability to generate random numbers, right? Yeah, we do. We have the ability to generate random numbers, and I'll demonstrate that on our calculator. We have the ability to say, for particular ranges of random numbers, we will call that a make, and for other particular ranges of random numbers, we'll call it a miss. So if I do something like math PRB, randint, and I get random numbers from 1 to 100, hey, I've generated a 95, and I'm going to say, for argument's sake, that if I get numbers from 1 to 80, that's a make. And from 81 to 100, that's a miss. You okay with that? So I just shot a ball. Clunk. I shot again. Air ball. I shot again. Nothing like that. Shot again. Another made it. Okay, I've just simulated 4 shots. Everyone okay with that idea?
Yeah.
Now I could do that 80 times, but you would get really, really bored. So the calculator actually has got another thing that we can use to make it faster. there's this thing called Rand bin. I'm going to try 80 shots. 80 shots?
50 shots.
50 shots, sorry. I'm going to try 50 shots, and I'm going to say the probability of success on any individual shot is 0.8. Now, if I hit this enter, it's going to go through, and it says 37. You know what that 37 means? 37 out of the 50 I made.
Oh, you might not be at 80% pretty
Here's another 50. 40 out of 50 I made. Exactly what's expected. Here's another 50 shots. 42 out of 50. Do you understand that each one of these is a simulation of 50 shots and saying how many I made?
Wait, one more.
One more?
Oh,
By the way, there's always this thing in basketball, who's got the hot hand? Someone shoots 44 out of 50 when they're at 80%. Oh, he's a... No, that's just chance variation. That just happens naturally sometimes when you're an 80% shooter.
He's got it. He's in the
No,
zone.
that's the hot hand.
He's in the zone.
All right? So, what happens if I do 400 simulations of 50 shots apiece? I get
Get a lot of data.
I get a lot of data. I get a lot of simulations. And that graph, that dot plot, is 400 simulations of 50 shots apiece. And right here, that dot right there, that could be that one of those ones where I got 41 shots. And this one is one of those shots where I got 42 shots. Now, I ask the question, at some point, moving away from 40 out of 50, moving away from 80%, at some point we get so far below what's expected as part of the chance variation that we don't think it happened by pure chance alone. So I shoot 32. I get 64%. Look at this. Only 3 times in 400 does an 80% shooter make 64% or less. My 64% shooting is really improbable, assuming I was an 80% shooter at the beginning of that calculation. If you assume I'm an 80% shooter, it's very unlikely to make only 32 shots out of 50. We might even go to say, based on this graph, that unlikeliness is 3 out of 400, based on that evidence. And what do we say when something's improbable? Probably there's a lie in there. Where's the lie? 80%. The 80% is a lie. Probable. Could it be an 80% shooter could get so low? It could happen, but it's very improbable. Jason's not willing to give me the benefit of the doubt. Are you, Jason? Not only will he say I'm not an 80% shooter, but he will tell everybody about how I lied.
Probably will.
Yep. All right. So, the observed statistic, meaning what Jason saw me do with those 50 shots, the observed statistic seems to be very unlikely given the assumption I'm an 80% shooter. So what do we think about the 80% shooter claim? It's false.
False.
The small probability is the evidence against that claim. Okay. So based on evidence, we may conclude the player's claim is incorrect. But in reality, there's actually 2 possibilities. One possibility is the player's claim is correct, but he just got unlucky. Well, I believe that there's chance variation. And I believe that 3 times out of 400 in our simulation, the 80% shooter did shoot that poorly. Now, if you want to call that luck, you just want to call that very, very different from what's expected, I'm okay with that too. One possibility is it was just a bad string. And that happens even to the best shooters. But the more probable is that the population proportion claim of 80% is wrong. And that that probability calculation is evidence against that claim. Do you see the two worlds? Could Jason be wrong by calling me a liar? He might
I
be.
could.
He could be, but it's very unlikely. And he's willing to take that chance. He's willing to slander my name out of 3 and 400 chances. Okay, just checking. All right. So here's the basic idea. An outcome that would rarely happen if the claim is true is evidence that the claim is false. An outcome that would rarely happen when the claim is true is evidence that the claim is false. Did you have a question? Yeah. Okay. Conrad, question? All right. Tell me when you're ready to go to the next slide. Anyone need more time on this?
Yeah, give me a second.
All right.
I'm good.
Ready now? Okay, here we go. So, let's start to formalize this procedure. This claim, the one that we're going to try to prove wrong, has a special name. It's called the null hypothesis. You're going to want to write this down. The first claim, the one that we think is false, the one that we're going to try to prove false, has a special name. It's called the null hypothesis. Sometimes the null hypothesis can be summarized as it's the no difference claim. My performance is no different than 80% shooting. My coin flipping is no different than a 50% chance of a hat. Now, there's what we think is false. We call it the null hypothesis, and then there's what we think is actually true. Jason thinks that I'm not an 80% shooter. We give that claim a special name as well. We call it the alternative hypothesis. Now, where are we going to make these claims? Well, we are going to use the 4-step process to do problems of this type. And like previous 4-step processes, we're going to start with 2 things in step 1. Oops, I wrote this backwards. I want population first. And I want parameter second. So if we go to this example that we just did, what is the population that we're investigating? This particular player's free throw shots. Okay. Now a parameter, some measurement of a population, for our first few chapters here in this next semester, are going to start with words like mean or proportion. This one, in fact, is a proportion problem. It's proportion made. Okay, and now we're ready to write in the specific language of statistics the null hypothesis claim and the alternate hypothesis claim. Now, in this particular one, by the way, we don't write the word out null hypothesis, we write H, and we put a little subscript 0, which the British call naught. So like P naught, yep. And we're actually going to have a P naught later.
Good one.
In fact, the stats search from a few years ago pictured me, my face, dressed up like Mr. Peanut from the Planters ads, except it was Mr. Peanut. But that's another story. Okay, my H naught claim, my null hypothesis claim, is what Jason said was false. What was false? What was false? That I'm an 80% shooter. I'm going to write this thing as false. P equals 0.8. I use the letter P because it's a parameter. He's not talking about just in one sample. He's talking about in all of my shooting. And 80% of the thing says that it's false. Not true. We follow it up with the alternative hypothesis. We'll call that the HA. The alternative hypothesis. And what does Jason say he thinks is true? That's what's going to go in the HA claim. He thinks my proportion of baskets made is less than 80%. It's a very vague statement. Because you know what? 79% is less than 80. He's got a lot of wiggle room there. He's not trying to nail down to a particular number. He just says, whatever it is, it's less than what you said it is. Because he knows I'm a bragger.
Or a dagger.
Or what?
A dagger.
A dagger?
A dagger.
I have no idea what that means. All right. Again, may I just, to help you through this process, I need you to have some words on which you can grab when you're doing this. It's going to be really difficult and very awkward to begin with, but you'll get used to it. The H naught claim, the null hypothesis claim, is what we think is false. But we've got to use that information in order to calculate the probability.
Why is blue good and red bad?
All right? You think this? We think this true. We're not sure. So, all right, we are just a bit into this. We've got another 15 slides to go. We will be starting right on time tomorrow. Some of them are summary slides. We're starting right on time. The homework assignment isn't going to be due till Wednesday. You could probably look at some of it, but you'll probably hit a wall pretty quickly. All right?
It will be a hard.
All right.